All right, hello chemistry students. I am here to deliver a video about railroad diagrams because there's been a lot of confusion and people getting upset about using railroad diagrams and choosing not to use them. And I wanted to post a video showing you why they're useful and what the general deal is with a railroad diagram. So this is using railroad diagrams for dimensional analysis. Now, I'm going to walk you through the entire process. We're going to go through all the key points. We're going to go through all the math. And I'm going to explain to you how it works as a multi-tool that you can use for everything in this class. Almost all the math that you use in this class will boil down to some form of dimensional analysis. So if you know how to use a railroad diagram in order to cancel units, it will take you a long way to solving problems, even ones that you haven't yet seen. So the key points for railroad diagrams. So if we can figure out how to manipulate the units of a problem so that they become the units of our desired answer, it will naturally lead us to the solution of the problem. This is probably the biggest one that you guys haven't really figured out yet. So far in your math careers, you've been used to manipulating numbers. And a little bit in algebra, you started to figure out how to manipulate variables such as x and y. You're not so used to taking the units that are involved in the problem and using them directly in order to come up with a way to solve the problem. What I'm telling you is that if you do that, it will lead you to a correct answer more often than not. In fact, almost every time. So the process that we're going to do, in order to convert from one unit to another, we have to cancel out the old unit, meaning we have to divide it by itself in order to make it 1, and then multiply by the new unit in order to incorporate that new unit into our problem. And then, so that we don't change the value of our answer, whenever we convert from one unit to another, we're always going to be multiplying by some form of the number 1. So for example, forms of 1 could be 2 divided by 2. Or they could be 1 foot divided by 1 foot. Or they could be what's more useful for us, 1 foot over 12 inches. Since this is a form of 1, since 1 foot is equal to 12 inches, this value is just multiplying. If we multiply by 1 foot over 12 inches, that's the same as multiplying by a form of 1. So we won't change the numerical value of our answer. So let me walk you through the concepts that are required for this mathematically. There are only 2 main concepts that you need to know. One is that anything divided by itself is 1, and we consider that to be canceled out of our work. So for example, if we take 2 divided by 2, we know that's equal to 1. In the same way, if we take a variable and divide it by itself, such as x divided by x, that's also equal to 1, and we know that intuitively. This x would cancel out. What I need you to get to is that if we do that with units of measure, it works the exact same way. If we take feet and we divide by feet, then feet cancels and we get 1. And if we take something more complex like moles divided by moles, moles will cancel and we'll get 1. So that's how we work to cancel out our existing unit. And then the other concept you need to get is that anything multiplied by 1 is equal to itself, i.e. the numerical value does not change. So here's how this concept works. So if we take 5 and we multiply it by 1, we get 5. The value did not change. And that's the case if we do that with anything, which I'll represent as x here. If we take any value and we multiply it by 1, we'll get that same value. X times 1 is equal to x. So therefore, it goes to, by logical extension, we can say that if we take 5 and we multiply by 2 over 2, which is just a form of 1, then that's also equal to 5 because we're just multiplying by a form of 1. So since 2 over 2 is equal to 1, if we take 5 multiplied by 2 over 2, we end up getting 5. And if we take if we take any number multiplied by 2 over 2, we get that same number. So what we can do is if we take 5 feet, if we now incorporate units, if we take 5 feet and we multiply by 1 foot over 1 foot, that still gives us the same 5 feet. Unfortunately, that's not very helpful because this is kind of like a tautological argument where, okay, 5 feet equals 5 feet, that's pretty clear, I don't need to know that. But here's where the utility comes in. Since 12 inches is equal to 1 foot, that means that 12 inches divided by 1 foot is just another form of 1, because it's one value divided by itself, just in two different units. 12 inches divided by 1 foot is equal to 1. And 1 foot divided by 12 inches is also equal to 1, because it's the same value divided by itself, which is our same concept as number 1. So here's where we can get utility out of this. If we take 5 feet and multiply it by 12 inches divided by 1 foot, so times 12 inches divided by 1 foot, we are multiplying by a form of 1, because we agree that 12 inches divided by 1 foot is just another form of the number 1. But what happens here is we've now changed the unit. We took feet and divided by feet, and since we know in concept 1 that anything divided by itself is 1, feet has now canceled out, and we're now in inches. So we take 5, we multiply by 12, we end up getting 60 inches, which we know to be equal to 5 feet. And the key point here is that 60 inches is equal to 5 feet. We know that intuitively, but we can also express it mathematically. So what happened is we took 5 feet, we multiplied by a form of 1, we get a new number value in a new unit, but that number value is still equal to the original 5 feet, just in inches instead of feet. That is the process by which we convert one unit to another. So let me quickly walk you through the overall process, stepwise, what you're actually going to do in the problem in order to use a railroad diagram. So in step 1, we're going to exploit the fact that we need to cancel out our original unit. So in order to do that, we're going to copy the unit we wish to convert into a diagonal cell. So we know we need to cancel out feet, so we're going to do that in the first step. We'll take feet and we'll divide by feet. We know that we're going to have to do that anyway, so let's just knock it out first step. The second step is we're going to write the unit we wish to convert to into a vertical cell. And we have to have a conversion factor between those units in order to do this. So we have to have something that equates feet and whatever we want to convert to. In this case, we're converting to inches. So let's say we know that 1 foot is equal to 12 inches, so we have a conversion factor there to convert between feet and inches. So we take the unit we're converting to and rewrite it in a vertical cell. So step 1, we wrote feet in the diagonal cell. Step 2, we wrote inches, the unit we wish to convert to, in a vertical cell. By the way, I should have wrote at the beginning that the problem we're trying to solve is convert 2 feet into inches. That's the problem that we're going to solve at the end of this. So we copy the unit into a diagonal cell. We put the unit we want to convert to into a vertical cell. And then, only after we have written our units, we use our conversion factor to make the top and bottom cells equivalent so that we're multiplying this 2 feet by a form of 1. So we need some value here and here of inches that's equal to some value in feet. And since we know that 1 foot is equal to 12 inches, that's what we put here. We need these top and bottom values to be equivalent. So that when we multiply 12 feet by this, we are just multiplying by a form of 1. We're converting 2 feet to another form of itself. So in the end, we multiply all the numbers in the top cells together, then we divide by all the numbers in the bottom cells, and that will give us the same value. So in this case, we take 2 feet, we multiply by 12 inches, we divide by 1 feet. That means feet divided by feet cancels, and we're left with inches. So the answer here would be 2 times 12 divided by 1, which gives us a total of 24 inches, which we know to be equal to 2 feet. That's the process by which we use railroad diagrams in order to convert between one unit and another, which is going to be a key skill. You can see we've already used it in dimensional analysis in converting metric units to one another. We used it for converting mole ratios in chemistry. So it's a very useful skill. We'll be using it very frequently. I hope this clears things up. Let me know in the comments if it doesn't, and I will see you in the next video. Thank you very much.